In this problem, we have an integer sequence A of length n and a sequence B of length m. We will make a new sequence A prime and B prime by removing some elements from A and B. But in the end, the final sequence A prime and B prime have to be the same size. Let x be the total number of elements that we take off from A and B to create A prime and B prime, and y be the number of integers I such that in the final sequences A prime and B prime, A prime I doesn't equal B prime I. And then we want to find the minimum possible value of x plus y. So this sounds really complex, so let's just break down the very first sample input. Oh, did not copy it. There we go. So this is sequence A, and this is sequence B. And let's say we take away this 3. So currently x equals 1 because we took away one element. And now let's say we stop here. So now this is A prime and this is B prime. And they're both the same size, so these are valid A primes and B primes. So now we can see that x is 1 and that's it because we only took away one element from A. Now y is the number of elements that don't match. So here in the first index, these match, these don't match, but these match. So only here in the in index 1 do they not match. So y equals 1. So overall x plus y equals 2, and this also turns out to be the answer. Right? So this is what the problem is asking us to do. Find this minimum value of x plus y. Now, the key thing here is to link this back to a well-known problem called the edit distance. And in this problem, what happens is you're given two strings, s and t. And we are trying to convert s into t in the least number of moves possible. And there are three types of move. One is an insert, one is a delete, and one is a replace. And in an insert, to make s into t, we could add characters to s somehow. We could add a DAS, DASD. So every one of these insert would count as one move. And in a delete, since we're converting s into t, this is one move, this is one move, this is one move, that is one move. So every delete counts as one move, and a replace counts as one move. So we could change this A into a D, and that counts as one move. And what I'm going to argue now is this problem is the exact same problem as the one we're given right now. So let's look at something like this. So now this is our sequence A, and this is our sequence B. Now, for them to be the same size, we have to remove two elements from B, right? And that is the exact same as the delete operation. And this would add to y, right? Because let's say to make these the same, let's assume we just take away the last two elements. Now they're the same size. So now y is 2, right? And this is also the same as saying we delete twice, right? So that makes sense, right? And next, right, we also have to keep track of x. And let's say in this case right now, let's say this is the best possible answer, x would be 2 because these two don't match and these two don't match. And this in the edit distance problem would be counted as a replace operation twice as well, right? To make these the same, we would make this 3 into a 5, which is a replace, and we would make this 4 into a 6. So they match the exact same. So this question is basically the exact same problem as the edit distance problem. We can just use that code, edit distance. So I think this code is from online somewhere, but the key thing here is that the values of A and B could go all the way till 1e9. So now what we have to do is we aren't going to pass it in a string, we're going to be passing it a vector. And this will also be a vector, and string and vector indexing is the same, so the rest of the code should be fine. And then we're given n and m. So let's read the, oops, would not need you. Let's give an int n m for n. Oops, let's create a vector int a of size n and b of size m. Then for n, c in a I, and then for n, c in bi. So now we read all our inputs. So now we just have to pass this into the edit distance function. So just be c out edit dist vector a vector. And yeah, that looks to work. Yeah, so in problems like these, it's just best to have practice and exposure. So yeah, and voila.